Let's continue using the network that we discussed earlier as an example. Let's now discuss problems with the forward route and their solutions. In this case, PC1 cannot ping PC4 with the IP address 172.16.2.7. Let's look at the example that displays commands used for isolating host-related IP routing problems on router A and router D, and some part of the router-related isolation process. The result of the ping command on router A confirms that PC1 is working well. However, the ping command on router D shows that router D is not able to reach PC4 as the LAN interface of router D has actually been shut down. Now let's look at another example that displays the traceroute command and forward route test results. In this example, traceroute 172.16.2.7 command on router A with the source IP address 10.1.1.1 displays that the traceroute command is not completed and results in router C having the IP address 10.1.13.3 as the last router. So we move to the forward route process in which router C routes packets to router D, that is 172.16.2.7. Now on router C, the show IP route 172.16.2.7 command displays the message subnet not in table, depicting that router C does not have a route matching the destination IP address 172.16.2.7. We can then use the show IP route command on router C and observe the routes to determine that no routes refer to a range of destination addresses that would include 172.16.2.7. When the problem isolation process points to a missing route, we need to determine how the router should have learned about the route. In this case, router C should have used RIP version 2 to learn about the route. In the example, as the router D has shut down its interface, it does not advertise the route for subnet 172.16.2.0/24 to router C. However, router C advertises an auto-summarized route to router A and router B. As a result, router A and router B can forward packets to router C that are destined for 172.16.2.7. This way, the traceroute command on router A can help forward packets to router C.